Okay, so today I'm gonna start like all my exam review stuff. I guess the first part is the first two units for polynomials. Um, Basically a polynomial is like a bunch of terms that are added and subtracted together. So like I don't know, 5x of that minus I don't know plus 2x plus I don't know 7x 0. Okay. Um, so you can see they're all being added. These are different terms being added and subtracted, and every exponent is a whole is an integer that's not negative. Okay, so if you see an equation or an expression with a negative power, a negative exponent, or like a fractional exponent or something like that, that's not a polynomial. And this term is basically a constant, so really we don't really need the x0, but by definition a constant is basically to the power has like a variable to the power 0, because anything to the power 0 is 1. So when you multiply this by 1, it's just itself, so that's the constant. For polynomials, you're usually gonna want like each term to be ordered in like a descending order. So like the highest degree, or the power, right? That's degree, um, to the lowest. So this is already ordered, but sometimes you might have to rearrange terms yourself. The degree of a polynomial is basically the whatever the highest power is. The degree of a polynomial function basically describes the functions and behaviors, which are basically describing which um, in which direction the function is moving on the left of the y-axis versus the right. So what do I mean by that? So let's take this function. So we know this is degree 3, which means it's an odd degree. Odd degree functions pretty much move from q3 to q1 uh, if the leading coefficient, which is the number attached to the variable, or like the number multiplied by a variable, right? If this number is positive, the end behavior is basically write it here. Odd, positive, Q3 to Q1. That's like pretty much the best way to write it, in my opinion. It's like the fastest. You could also say like uh, as x approaches negative infinity, which is basically left of the y-axis, um, y approaches like negative infinity, and then like as x approaches infinity, y approaches infinity. Like, but like that's very long, so just do that. If the coefficient of the leading term, um, basically the leading term is basically whichever term has the highest power, right? So if the leading coefficient of that term is negative, um, that would reflect the function along the y-axis. So now now the function goes the end behaviors of that function goes from q2 to q4. For an even function, uh, for an even degree function, the simplest being like x squared, right? They're different. These are pretty easy to remember, I guess, but You could either memorize this like directly, I guess, or think of a linear line and a quadratic like parabola. So if the leading coefficient of an even degree function is positive, the end behaviors go q2 to q1 because, a parabola goes like this by default, q2 to q1. And then if it's negative, it goes q3 to q4 because it would reflect. So, just think of the linear line, which is like that, and think of a parabola, and you know, you'll get it. Now, even and odd degree functions should not be confused with even and odd functions. So that's something we also need to know. So an even function is defined as f negative x equals fx. So it's basically like if we again take the parabola, which is an even function, um, you know, like f negative x here, let's take that, and f positive x, like the same number but different signs, they're on the same, like they have the same y value, okay? An odd degree, not odd degree, an odd function is defined as f negative x equals negative fx. This holds true because negative f of x is basically like you take all the y values of the function and make them negative, so you're reflecting it on the x-axis, right? So this is a reflection along the x-axis, while this, right, if you make all the x values negative, you're flipping it along the y-axis, right? This holds true because in either case, the function would look the same. So let's take, for example, x, this is roughly what x to the power of 3 looks like. Not really, but anyway, the main thing is that if you flipped it along the, y-axis, like this is, you would get something like this, okay? Now if you take this and like imagine a 3D space where you flip it like this way, right? Like, you know, like, yeah, you flip it, like you put it on a piece of paper and then you made the backside like front by flipping the top to the bottom, it'll look the exact same. So that's why odd function, this definition holds true. Another important thing to note is that even functions have line symmetry. Oh my goodness. They have line symmetry, right? So if take this quadratic, right? If you took a line and like split it down the middle, right? Both sides of that line would look the same. Like if you took one line and then folded it to the other side, it would look the same. Odd functions have point symmetry. So if you took this function and you rotated it along the origin point, like 180 degrees, I think, it would look the same, right? But it's important to note that it's only along the origin point. If you took this and like if we take like this, and let's just pretend this is like x cubed plus 1 or something, this no longer has any symmetry because it's not symmetrical along the origin point. So yeah, not all even and odd functions, like yeah, all functions would have like would be even or odd, but they may not always have symmetry. I take that back. Not all functions are even or odd. There are definitely functions out there that neither of these, if you do the math, neither of these definitions hold true. So in that case, that function would be neither even nor odd or odd, whatever. And that would also mean that they don't have symmetry either. The next thing we need to know is graphing. So let's see, let's turn that to meaning grid. So the easiest way is to graph using zeros. To do that, we're gonna need a couple things. The first thing we need is the degree of the function. No. Okay, so the first thing we need is degree. The second thing we need is sine of leaf coefficients. I don't even know if that's how you spell coefficients. Actually, I'm not gonna say graphing. It's more like sketching, because I don't like class in school. I don't really need to do like precise graphs. So we need degree, sine, and of course the zeros or the roots. It's important to note that there are three different types of roots. Yeah. The first type is a linear root, meaning that the function passes straight through. The second type is like a cubic, so it kind of like looks like that. And then the third type would be like quadratic, where it touches it and then it kind of like rebounds. So yeah. Another thing that you'll need to graph or sketch, like make an accurate sketch, is the y-intercept. It'll help make your graph more accurate. So let's do an example question to show everything in action, like the whole process. So the function f of x is equal to negative 2x to the power of 4 plus 8x to the power of 3 plus 10x squared. There's no constant because you don't really need uh, all the sort of terms, because like this function could be missing the third like degree term, but this is still a polynomial function. And it's even missing the first degree, like 1 degree term, I guess, if that's what you call it. So yeah. Looks pretty long and ugly right now, but to break it down, make it more simple, we're gonna factor. So common here, just common factor out -2 because all the coefficients have -2 as a common factor, and all the variables have a common factor of x squared. So now that minus 4x plus 5, this is just a simple trinomial. Oh, not plus 5, minus 5, my mistake. So it was -4, -5, plus 1, negative times 1, so then this is -2x squared, x minus 5, x plus 1. Right? Oh shoot. Cool. So now we just set each sort of term in here to 0 to determine the roots. What the hell? This is still 0 because like -2 0 divided by -2 is still 0, and then square root 0 is 0, right? And then determine our y-intercept. So -2, 0, 4. And that whole thing just multiplies to 0. So now we can finally graph it. Oh, and one important thing to mention. So I mentioned these three different types of roots. In each bracket here, you using like the degree of the 0, or like bracket or term or whatever after you factor everything, you will use the degree to determine what type of root it is. So because this is like an even degree, it'll be a quadratic type root. Because these are degree of 1, these will both be linear type roots. That's very important to remember, so your graph is so your sketch is accurate. I'll just do it like right there, I guess. So 1 0 5 0 0 0, and we just remember the leading coefficient and degree of the function. So this is an even degree function with a negative leading coefficient, which means the end behavior will be q3 to q1. So linear type root. Oh gosh, what the fuck is going on? Linear type root, quadratic type root, linear type root, and then saw your arrows. That's it. That's like there's the most simple way to graph it. So degree, sine of lead coefficient, 0 is y-intercept. Yeah, that's it for part 1. And then part 2 will be like equations and inequalities and other things. Oh, wait, there's one more thing. Okay, one last thing to note is this formula f equals c multiplied by d factorial. Um, you'll see different letters sometimes, I guess, but like it doesn't really matter. F is the finite difference, so in like a linear like table of values, the first difference is that's your finite difference, and then in a quadratic, your second difference, that's your finite difference. C is a leading coefficient, and D is a degree of the polynomial. So let's do an example. -12 equals C multiplied by 3 factorial, and we want to find the leading coefficient. 3 factorial is essentially equal to 3 times 2 times 1. So you count down from this number and multiply it by all numbers like below it, all integers. Another example is like 5 factorial will be 5 times 4 times 3 times 2 times 1. So to solve for C, we basically just do C equals -12 divided by 6, because 3 times 2 times 1 is 6, and that equals -2. That's your leading coefficient. So it's a simple formula, but you might need to use it. That's it for part 1.